Okay, so here's another function. Let's graph this one as well. And then, of course, to graph a function just means to sketch its graph, right? Okay, so, well, what do we got? We've got a function g defined by the rule g of x is equal to x squared minus 4. So, okay, well, how do we start this? We're going to start with our table of values, right? And we're going to have to pick some x values to use. Remember what I said before, if you don't have any reason to do otherwise, I recommend just picking a handful of values. Usually take 0 to be one of them, and then just pick a couple that are smaller than 0, so a couple that are negative values, and then a couple that are positive values. And these values will probably work just fine. Okay, so then what are we going to do now? We're going to plug them into the function, and we're going to figure out what the corresponding y values will be. So if I plug in -2, I'm going to get -2, plug in -2 here, right? -2 squared is 4. So you subtract 4 from that, you're going to get 0. Okay, and then if I plug in -1, I'm going to get -1 squared minus 4. Well, that's just 1 minus 4, so I get -3. If I plug in 0, I'm going to get 0 squared minus 4, which is just 0 minus 4. And similarly, you can check that g of 1, is -3, and g of 2 is 0 as well. I'll leave it to you to check the details there. But that gives you enough now to plot some points, and then you can get an idea of the shape of the graph. Again, so the point -2 is 0, so a -2 on the x-axis and a 0 on the y-axis, that's going to be your point -2, 0. The point -1, -3, that's this point here, and the point 0, -4. Remember, the first number is always your x-coordinate, and then the second number is your y-coordinate. So the next one will be 1, -3, and then 2, 0. So you may, in general, you may decide that 5 points is not enough, right? It might not always be enough to get an idea of the shape of the graph. Some more complicated functions, you might want to do more points. But in the end, drawing graphs in this manner is actually never going to be perfect. You're never going to know for sure. All you can do is get a nice idea, get a kind of a rough idea of what the graph looks like, and then just make an educated guess. So for example, like in this case, we're going to kind of make a guess that the graph follows this shape, but we don't really know 100% for sure, right? But we get it. That's a pretty good guess. Okay, and this allows you to pick out some pieces of information. So you've got a y-intercept of -4. That one you do, that piece of information you do know for sure, because that was one of the points that we actually plotted. So the y-intercept is for sure -4. The x-intercepts, well, again, we happen to know those for sure because we know exactly where we know for sure that those points lie directly on the x-axis, and that's what it means to be an x-intercept. It means to be a point that's on the x-axis. So because it hits the x-axis at the point -2, we say that -2 is an x-intercept, but it also hits it at +2. So that means +2 is another x-intercept. So we could say -2 and +2, but what you typically will do is you'll just do this. You'll just say plus or minus 2. Okay, so that's how we will summarize the intercepts. Okay, and like I've said with a lot of other things, we are going to talk more about intercepts actually on the next page. Okay, but that's as much as I want to go into now for table of values, because like I said, table of values as a method to graph functions is really crude, and it only works to give you a rough idea, but we'll want to rely on better techniques later on. But let's move on to the idea of the vertical line test. So the vertical line test is what tells you, if I give you, what if I, like, look at this case. We were given the actual definition of the function, and then we came up with the graph. What if we didn't have this, right? What if you didn't have the rule and all you had was a graph? Can you recover the definition of the function? And the answer is yes. Technically, you can do that. But if I just throw any graph at you, there's no guarantee that it's going to actually be the graph of a function. And there's a test that you can use to figure out whether or not it will. And this is called the vertical line test. So it says that if you have a curve, curve is just another word for graph, right? So you have a a curve, it might even be a line, but a curve is just the more general of the two words. So you have a curve going through two-dimensional space. Here's an example, and here's another example. Here's an example, and on our previous page, here was another example. That's technically a curve. It just happens to be a straight line as well. But a curve in the Cartesian plane is the graph of a function if and only if, here's the key part, here's where the vertical line test is really stated. Every vertical line that you ever draw can only ever touch that graph at one point. If it ever hits any vertical line at more than one point, well, then it's said to fail the vertical line test, and then in that case, it's not the graph of a function. So here's two examples, and we're going to figure out which of these two graphs are actually graphs of functions. And maybe neither of them are, maybe both of them are, maybe one is and one isn't. The vertical line test is how you will determine that. And this is actually one of the cases where it's actually handy to have a tablet, because I can draw a vertical line. It has to go on forever in both directions. But now, the idea is I'm going to slide this along the x-axis and ask yourself, is there any place where this curve touches where this vertical line touches the graph more than once? And I'm going really slow here because I wanted to finish that question before I got here. But now you can see that the answer is, right when we get to here, once we get into this region, right? This is where the problem region is. Once you're in here, you actually hit the graph 3 times, right? There's a point here where that vertical line intersects with the graph. There's another point here, and then another point here. All 3 of those points are points of intersection with that vertical line. So the vertical line test fails. Or again, is it the test that fails, or is it the graph that fails the test? I guess it would be the graph that fails the test. So it's not that the test fails, it's that the test is failed. So let's I guess write it that way. So the vertical line test is failed. So your conclusion then is that this curve, or you could say graph, does not define a function. Okay, so there you go. That's part A taken care of. Let's look at another example. By the way, why am I starting from the right and moving left? No reason at all. I could just as easily start over here and move to the right. Okay, so let's start here. If I take this vertical line, I just slide it all the way along the graph. Ask yourself, is there any place where this vertical line intersects the graph of that curve, or intersects that graph, I should say, more than once? And the answer is no. All the way along here, it only ever touches the graph at one point. Okay, so that means, what about over here? It doesn't intersect the graph at all. That's okay. It doesn't have to intersect the graph. That's not a problem. If it doesn't intersect the graph at all, no problem. It's only if it intersects the graph at more than one point. So since this line doesn't, anywhere along here, it doesn't intersect the graph more than once anywhere, we say that the vertical line test is passed by this function. So this curve passes the vertical line test. And I'm going to just to emphasize that, let me duplicate this and just make a couple lines, because in case you're looking at your notes later, I don't want you to be confused and think that you only have to draw one line, because you have to draw many lines, right? You have to consider every possible vertical line that you could draw, not just one line. So I'm just going to duplicate this and add a couple more to make it clear later that we're talking about every possible vertical line you could ever draw, right? And you can see that, and it's easier to see now because you got a whole bunch of lines. You can see that they only, each of them only intersects the graph at one point. Okay, so what's the conclusion? Therefore, this curve does define a function. Okay, but how? What's the rule? Right? If I say I'm able to use the graph to define the function, I should be able to tell you what the rule is. If you give me an input value, I should be able to tell you what the output value is. So how do you do that exactly? Well, we're going to take a look at that on the next page.